Okay, guys, I hope you didn't fall for that trick. Some of you wanted to just continue to add 35 each time, but look, they broke the pattern right here. Went from 3 to 5, then they went 5 to 8, then they went 8 to 10. So you should have gotten 90, 125, 195, 300, 370. So if we label this, this is going to go, this is our input, also known as our x-axis. That goes into the machine happens, and out comes the output and the y-axis. So now we've got to create that graph. So draw your lines. We only need the first quadrant because we're all positives. All my x's are going to be positive, all my y's are going to be positive. And let's label. Which one goes on the bottom, guys? The input or the output? The input, very good. And if you look at the input here, you have depth of kilometers. So we're going to put depth in kilometers here. And the output is temperature in degrees. So we're going to put temperature, and then Celsius is degrees. Now let's talk about a scale for my x. Remember, the scale for x and the scale for y do not have to be the same. My x's go from 1 to 10, and I can fit that here. So I'm going to skip a line, go 1. Skip a line, go 2. 2.5, 3. 3.5, 4. 4.5, 5. 5.5, 6. 6.5, 7. 7.5, 8. What happened? I ran out of room over here, and I've got to get 10. So, God bless erasers. Let's try again. I don't think I can skip a line, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. Okay. Now, our temperature has to go from 55 all the way to 370. So I say we go by 25s. 25, 50, 75, 100, 125. Oop, are we going to fit? I hope so. 125, 175, 200, 225, 250, 275, 300, 325. Oh my gosh, we're just going to make it. 350, 375. Whew, okay, so it's perfect. So let's graph these. At a depth of 1, so this whole line, it's got to meet up at 55. So put your finger on 1, put your finger on 55 degrees, meet up in the middle, and it's probably right about there. Put your finger on 2 kilometers and 90 degrees Celsius, make a meet up. 3 jumps to 125, so I put my finger on 125, I put my finger on 3, and they meet up right there. 8, so skip all the way over here to 8, needs to match up with 300. So take your finger on 300, take your finger on 8, go ahead and match them up, make a dot. And then we've got 10 and 370. So 10, and here's about 370. They meet up right about here. All right, so we've got a positive slope going on here. Use your table or graph to help you answer the following questions. Explain how you found your answers. Find the temperature of the rock at a depth of 3 kilometers. Well, 3 kilometers, I'm just going to go straight to my table because I already told it it's 125 degrees. And I used the table for that one. Find the depth, down here, if the temperature of the rocks is 195 degrees. Well, look, 195, is right there. And so what's the depth? 5 kilometers. I used my table again. If they asked you, say you wanted to do that. If they asked you, how many degrees is it at 6 kilometers? 6 kilometers isn't on my table, so I'd have to come over to my graph, find 6 kilometers, come up to my line, and then come over, and I could say it was about 230 degrees Celsius. It's pretty hot. Okay, good. One more. All right, we must create tabular, that's a fancy word for a table, create a table, and an algebraic representation, that means a rule, for the information shown in the graph. Piece of cake. They already did most of the hard part for us. The input down here is the number of tickets sold. I see a dot at 1. I see a dot at 2. I see a dot at 3, I see a dot at 4, I see a dot at 5. Let's think about what we have to put here. Now, the output is the amount of money collected. So let's see, I say that's just about $5. So $5. At 2 tickets, it's exactly $10. At 3 tickets, I'd say 3 tickets is right about $15. 4 tickets, according to the graph, is exactly $20. And 5 tickets is just about $25. So stop and think, what is the process? Now, I know a lot of you are, well, Ms. Oxley, it's going up by 5. That wasn't the question that they're asking us. I'm no longer asking you, how is the output changing? I'm not asking you that question anymore. I'm asking you, what is the relationship between the input and the output? And the relationship here is, there's the bell. You're going to take your input and you're going to multiply it by $5 each time. No matter what your input is, you're taking it and you're multiplying it by 5 every time. If I put a 5 in here, 5 times 5 is 25. If I put a 4 in, 4 times 5 is 20. Piece of cake. What's the rule? Should my rule start with x equals or y equals? Good, it's always output equals, so it's going to be y equals. Always write my x and then think, okay, well, I had to take my x, my input, and multiply it by 5. So a lot of people are going to go like this. And that's okay, as long as you don't write that as your final answer. That is not algebraically correct. Instead of writing x times 5, we have to write 5x. Would you be mathematically correct? Yes. But in algebra, writing it like this is like misspelling a word or not capitalizing the first letter of a sentence. The audience is going to know what you mean, but you're going to sound a little funny if you put that. So make sure you put that. All right, guys. Good luck on your staying sharp.